Hey guys, how are you? So, let us introduce our project. Please do support us. Our project is Sewage Water Treatment Plant for Pisciculture. So let's get into its details. Before getting into it, let us introduce ourselves. We are a team of 4 members, guided by our mentor. So what is our project? Our project is a solution for the major problem faced by fish farmers. As we all know, for pisciculture we need to change the water once in 2 weeks for the better growth of fish. But the source for that is now be a question mark. Let's see how we can find the answer for that. In our surroundings, a lot of water gets wasted every day, like drainage water, rainwater, etc. Can we collect it and use the purified water in our own way? Yes, that's possible in our project. Our project is Sewage Water Treatment Plant for Pisciculture. It is a better way to do that. Let's move on how it purifies the water, its parts and the processes.
This is our first tank. There is an inlet to this tank. The sewage water or our waste water which is to be treated is moving to this tank in this way. Here we are fixing a solenoid valve. When the solenoid valve turns on, the water is moving to this tank. Let's see the inside of our tank. Here we can see a filter and a level sensor. When the water comes to this tank, the large solid particles get settled down in the left side part. When the water level reaches a particular level, the level sensor detected that level, and then the solenoid valve which is connected in the right side of the tank gets opened and the water in the first tank is moving to the second tank. The water from the first tank reaches the second tank through this valve. Let's see what's inside the second tank. Here there is a DC motor and a paddle wheel is connected to the end of it. And there is a level sensor and a servo motor. Servo motor type arrangement. I will show you what is this. When the servo turns 180 degree, let's see. This gets opened. And when the servo is getting back to 0 degree, this opening gets closed. Let's see what's happening inside this tank. When the level sensor reaches a particular level, the DC motor starts rotates, so that the padding wheel starts rotates and it mixes the water well. So then when the DC motor starts rotates, the servo motor turns to 180 degree, so that we are filling some chemical which is known as alum in this part, so that when the servo turns into 180 degree, that alum gets fall into this water. Alum is used for purifying water and it removes the turbidity also. We will leave it for almost 5 to 10 minutes so that the alum gets mixed with the water and the turbidity turns into clear water. Then after 5 minute delay, the solenoid valve in the right side of this tank to the third tank gets opened and the water from the second tank moves to third tank. The arrangement of second and third tank is almost similar, but there is a difference. Here we are using ferric chloride instead of alum for removing the phosphorus content in the water. That is the only difference between second tank and third tank. After as the same as second tank, we are giving some time delay, that is 5 minute time delay in this tank, and then the water that gets moved to the fourth tank, that is our glass tank. There we are removing the microorganisms, harmful microorganisms in the water. This is our fourth tank, that is a glass tank. Here we are fixing a UV lamp which is used for the purification of water, that is which destroys the microorganisms. And here we are fixing a water level sensor. When the water level reaches a particular level in the water level sensor, the inlet valve, that is the inlet solenoid valve, closes and the UV light starts light. The UV lamp turns on for particular minutes, and after a few minutes that light turns off, and then the outlet solenoid valve opens and the water which is moved to the next tank.
In this video, we are going to see the turbidity of our resultant water after treatment with respect to the clear water. The sensor pins are connected to 1, 2 and 4 respectively, and the ground is connected to the Arduino ground, and the voltage is connected to the port of Arduino with 5 volt. Now let's see what's the turbidity of clear water. Now the resultant of the clear water turbidity is with the value 3.22 as you can see in the monitor. Now let's see the turbidity of the turbid water that we obtained is 3.25.
The result of our process is that we are getting pure water and can be used for various purposes. Here you can see 3 cups. First one is the sewage water, the second one is the output that we got, and the third one is the reference pure water. Now you can understand how successfully we completed the process by getting a better purified water when compared to the sewage water. Thank you all for listening our presentation patiently and being a part of it. Thank you.